Zach, thank you so much for joining us on this. This is kind of like a podcast we set up. We're exploring everything from different services that we've offered to products we offer. We're talking about bolting in general. And then we brought you in because we want to talk about fasteners. Before we jump into it, if you want to take a minute, just kind of tell us who you are, what you do here, it'd be great.
Yeah. Well, thanks for having me on. It's a pleasure to be here. My name is Zack. Started with HYTORC, 6 years ago now, I want to say. Started in the customer service department. I have a degree in mechanical engineering, so I had the mindset of tracking upwards into, a more technical role that maybe wasn't fully engineering within HYTORC. So customer support was a great place to start. Let me learn the business. Let me learn what we do. And now I'm on the product management team, product manager for the Fasteners, and just focusing on anything from marketing to sales, development of new products that will support the fasteners or new products with the fasteners, and just anything to do with our fasteners I've got my hand dipped into, really.
When it comes to industrial bolting, what are some of the common problems that people face when they're trying to achieve that precise torque, but without having any of the damage, damaging equipment or any safety issues?
Right. Well, the first thing I'd say is having the correct equipment to do the job. A lot of these jobs, like the name of the company, they have high torque. The torque values that you're trying to hit are very high. And, one of the first videos that I saw when I was brought on to HYTORC was, it was at a refinery plant. These guys trying to torque a bolt down on a pipe joint, and they had a 6-foot-long torque bar that they were hanging on. And in the piping industry specifically, torque's very important. You're not getting precise torque there. So first is what tool you're using. And then, once you have a tool that can do the correct torque, are you able to brace the tool correctly so that it can deliver that torque? Are you bracing it on something that's sturdy enough to actually brace the torque? You're going to damage that thing. There's a lot of different factors that, play into, am I doing the job correctly? Different industries require different things, but at the end of the day, if you have a precise torque job that you're looking for, it's all about the tooling and what you're using with the tools to allow the tool to do the best job that it can.
Gotcha. And then I would imagine typically it's going to be more reaction arms, backup wrenches, and things like that. What are some of the common issues with those as you see?
Yeah. So one, I would say they can be cumbersome. HYTORC, other companies that make these torque tools, they're going to give you a standard reaction arm for that tool. Will that reaction arm work for the job that you have at hand? Maybe it will. Maybe it won't. And if it doesn't work, then we have to figure out, what kind of reaction arm will work? Oftentimes, they could be large arms. Now your tool is getting heavier. It can be a little bit more cumbersome to use. And also, maybe it's not that easy to figure out a way for a reaction arm to work. Maybe there's nothing around that you can react off of. And then you're stuck with another issue of, okay, I don't even know where to react, let alone getting the type of arm that could allow me to react in a certain spot. So that presents a whole nother issue, and that could be another job delay.
Well, and that's also not talking about necessarily the safety issues on top of that as well.
Right, yeah. Let alone the safety issues. I mean, these reaction arms, a lot of these tools are doing torque up to, you'd be looking at 10,000 foot-pounds. And let's say you had a reaction arm that was, reacting a foot away. To brace the tool, that reaction arm is going to be pressing up against a spot with 10,000 pounds of force. What can happen sometimes, unfortunately, is a tool operator may not be communicating well with his team, somebody's not paying attention, and a finger can get mistakenly placed underneath that reaction arm. You got 10,000 pounds of force going onto your finger. That's a safety hazard. Yeah. That's how people have lost their fingers in the past using reaction arms. Yeah. So it could be a job time thing, or it could be a safety thing, and as a lot of companies know, you have a safety issue, that's going to stop a job for a long time. Yeah,
I was actually going to bring that up too, with downtime and everything. Have you ever heard or even seen yourself a scenario where that happened, whether it was from an injury or something, as a result of the bolting job where it led to that downtime?
Right, yeah. I mean, I've heard actually firsthand from some people at trade shows who have experienced that firsthand, where I'm actually talking about this issue with them, and they'll hold their hand up and they'll say, that actually happened to me on the job. And then, you have the other side of it where you see the effects of what happens to a company or the job at hand when somebody gets hurt. That job shuts down. Tons of paperwork is involved. All different teams get called in to figure out what happened, and it's a huge halt to a job. And depending on the job, if that machine is down for more than a day, it could be tens of thousands, millions of dollars that are being lost. So, there's the human safety factor of it, but then, the economy of it as well.
Yeah.
Machines are going down.
So now
companies lose money.
Now with these fasteners that exist, like the washer and everything, we'll call everything else sort of the outdated methods of that. What are the long-term risks that a company faces if they just continue to use these outdated methods?
Yeah, I mean, there's definitely a few that I've seen firsthand. One being, with the reaction arm, you obviously have the overlying safety risk. But with the reaction arm, you also may not be getting consistent torque values. Okay. So if you were looking at, the pipe flange with 20 bolts and you were measuring how much load each bolt got and you were using a reaction arm, depending on what you have available, the load that gets put onto that bolt may not be exactly the same across each bolt. In a scenario like that, you don't have consistent loading around that pipe. That's where you can get leaks. Things aren't sealed correctly and you can get leaks. So then, whatever's being transferred through that pipe, you're losing however much is leaking over time. That's going to, drop job efficiency. And
does that affect also the lifespan of that?
Yeah, a lot of it's application dependent, but if you have a, load critical joint, if you're having consistent load over all those bolts, that's going to be something that's going to increase the longevity of whatever that application may be. The other thing that it does is when you're using a reaction arm, it's putting interesting loads on the tool that you're using as well. So if you're not using a reaction arm 100% correctly, that's going to make it even worse. So by using a reaction arm, you're losing out on efficiency on the actual bolting job that you're doing, and you also may be losing out on the lifespan of the tool that you're using.
Gotcha. Yeah. And has there ever been a instance where you've seen how a job was done, maybe they had an issue, maybe it led to downtime or an injury, and you immediately were like, yeah, that would have all been solved had they just used, the washer?
Oh, yeah. I mean, basically every single one.
Yeah.
There's, there are areas where, our reaction washer wouldn't work. There are very few, though. In our world, with everything that I've seen, it's like almost every application I see, we should throw a washer on there. Yeah. It would solve all the issues that you're currently having. It's almost like every application. It's rare that I see them where I actually am able to admit, like, it's not going to work here. But I'd say 95% of everything that I've seen, it's like all bolting problems would be solved if you threw our HYTORC reaction washer on there. Yeah.
And now, so for someone who just no clue what we're talking about, like what a washer is, what does the washer do to actually address those challenges? Yeah,
so our washer, well, to back up a little bit for people who don't really know much about bolting at all, standard washers, the disc you would see underneath your hexanut, and that helps distribute load evenly across the surface because maybe bolt holes aren't exactly the same size, and it helps keep things consistent. So you see washers spec'd into everything. You look at standards for bolting across any industry, you're going to see washers that are spec'd in. Our HYTORC reaction washer has the special pattern around the outside of it, and it's also got some knurling. The combination of the two allows us to eliminate the reaction arm. So all those things that we were just talking about with, inconsistent reaction points being bad for the tool or, bad for the job in terms of consistent bolt load, and the safety issue of potentially getting your hands or fingers pinched, our washer solves all of those issues all in one. And it's really great because it's just a washer, and then you just get a special socket for it that work with our HYTORC tools, and it makes the job so much easier, safer, more reliable.
And then as a result, obviously, you don't need the reaction arm or a backup wrench because you have the backup washer and then the HYTORC
washer.
Right,
yeah. So we have the backup washer as well, which I didn't mention, but the backup washer, would go on your passive side of whatever joint you're bolting, and you can eliminate an operator standing on the backside. using the HYTORC washer system as a whole is just going to increase your job efficiency, your job safety, and the overall quality of the job, especially when you have both the backup and the reaction working in tandem.
And then, so you mentioned before the knurled pattern that's on the washer. So can you talk more about that? Like, how does that prevent the rotation that's on there? How does it ensure the precision that it does?
The concept of it all is you're bracing the tool. If you're turning a bolt or a nut on a bolt, and you're turning it with a lot of force, that tool needs to be held in place so it can actually turn that nut. So you need something to create enough force that we call the reaction force for the tool. So the washer, the two main features being that outside pattern, that flower pattern, and then the knurls. So the knurls are going to go face down on whatever you're bolting. So your nut would sit on the other side of the knurls. And once the nut is just hand tight, like literally you could, any size bolt, you could go up to there, tighten it with your hand. If you then went to try to turn the washer, it's not going to move. And that's because the pressure that the nut creates combined with those knurls, it creates enough friction to prevent the washer from spinning.
Gotcha.
The tighter the nut gets, the more friction that's created, so it's even more resistant to spinning. So the tighter the bolt gets, the more resistant that washer is to spinning. Gotcha. So we're able to grab the nut, turn it, and simultaneously grab the washer to react. And then you have everything contained in this one small area instead of turning over here while reacting over here. It's 2 points to look at. Here, we slap the tool on because of that knurling and that outside pattern, and just keep everything contained in one spot.
So then at the trade show, what was the reaction from people who were there?
Yeah, so with the trade shows, it's actually really cool to see because you'll get guys that come up you get all sorts of people that come up to you at trade shows. But it's really cool when you get a guy who actually knows tools and knows what he's talking about, and he comes up and we're demoing the HYTORC reaction washer, and comes over and he says, well, where's the reaction arm? And then he doesn't believe anything that we're doing, which is really cool to see because you then get to talk to somebody who's been out in the field and knows what they're talking about, and getting to show them why there's not a reaction arm and everything that goes into it, and seeing them go through the doubts to the aha moment of, oh my God, this is awesome.
And it's kind of funny too, because I feel like once you explain it and you look at it, you're like, oh, that makes sense.
Right.
But initially it's sort of that, well, we have the tried and true way. So you're like, clearly this is not even tried and true. This is the only thing that exists. Like nothing else exists. And you're just like, what? No, here. And then there's, what? And it's just like, it takes a moment to process, but then as you explain to them, they're like, that actually makes sense. And then it's just immediately starts clicking all the safety benefits of the efficiency benefits
and
of it.
And then for them too, it's even like, well, why am I doing that when this exists?
Yes, exactly.
Well, that's why we're here, spread the word.
Have we done anything to compare kind of how that works against sort of alternative washers?
Yeah, so with the J washers, we mentioned the vibration machines that we've done our younger testing on, and we've tested against some of the competitor locking fasteners. If you were to go online and Google locking fasteners, you're going to see split lock washers, which are those washers that it's got a cut in it, and it almost looks like it would be a spiral if it kept going. You've got those. You've got the Belleville washers, which are just regular washers that kind of have a conical shape to them. They're almost cupped a little bit. Double nutting is a solution for a locking fastener. So, two nuts stacked on top of one another. And then you have the elastic lock nut, which, is a nut with a little nylon elastic band at the top. These are all, competitors or competitive solutions, I should say, that claim to be locking fasteners. And I've done side-by-side tests on our vibration machines, did them at the trade show actually, and you can see, even with like a split lock washer, we had our two machines side-by-side. We had the J washer on one bolt, the split lock washer on the other bolt. Flip both machines on after tightening them down to the same exact torque, and you could see the nut on the split lock washer turning off, loosening as our nut held. We would turn the machine off with the split lock washer, retighten it while the J washer machine was still running, turn the split lock washer machine back on, J washer still holding, and again, split lock washer going off. So I think it really goes to show how, confident we are in our product. We're out here at shows doing live demonstrations of these things and showing that these other quote unquote solutions are not solutions. Yeah. And we've got it.
Well, and many of them, unless I'm wrong, I would think many of them also still require the reaction arm and everything.
That too, right. Yeah, all of those other competitor methods that I just mentioned, every single one of those needs a reaction arm as well.
So you don't even get the benefits of like the J washer in just for the vibration alone and the reaction arm part as well.
Exactly, yeah. So it's like, killing two birds with one stone with the J washer. You're increasing safety, job efficiency from the reaction washer features, plus getting the locking feature from that topside knurl.
And then before we kick you out of here, we have our training center set up. I was hoping that you could kind of run through the washer system and kind of show us how it's used and what people do and how simple it is.
Definitely, yeah.
Awesome. Let's do it. All right, so Zach, what are you going to show me on this then?
We're just going to walk through a quick live demo of our washer system. So we've got our reaction washer, which is right here. And then we have our backup washer, which is right here. So starting with the reaction washer, this is going to go on the side that you're actively torquing. You have your knurled side and your flat side. And then you have this pattern that's around the outside diameter of the washer as well. The knurls is what's creating that friction that I mentioned earlier. So once we tighten the nut down onto it, the amount of friction created is enough to resist rotation of the washer. So we put this down, knurl side touching the material that we're bolting. You can also actually notice that this is got a little bit of a chamfer on that knurled side that is going down onto the bolted surface. And then we have our backup washer, which is just a plain circular washer with knurling on both sides. This goes onto the passive side of our flange. This is going to eliminate the need for a backup wrench. So you could set this here, get this hand tight back here, and that will hold that nut in place. I'm just going to wind this down real quick onto here. And another thing that I mentioned earlier, with the friction that's created with these knurls, right now, the nut is not touching the washer at all, so we're able to freely spin this washer. To demonstrate how effective the knurls are, I get this down to hand tight, and I go to try to turn this, and I'm really trying. It did budge a little bit there, but I barely torqued this nut down. So what's going to happen is I've got a HYTORC Lithium Series 2 here with our washer driver. It is a two-piece socket. It's got the inner socket that's going to turn the nut. As you can see, that inner socket is spinning. And then we have the can on the outside. That's our reaction can here. That's going to hold the washer and give us the reaction force needed to torque the bolt to the torque that we want. And we've got this thing set to 300 foot-pounds. And you'll be able to see that all I need to do is set the tool on there, making sure that my driver is fully engaged on the washer. And then all I need to do here is pull the trigger and let the tool do the work. Now this socket on the inside is turning. It's torquing the bolt and everything is enclosed. I cannot pinch my fingers at all. And just like that, that was 300 foot-pounds. This thing is tight. I didn't need a backup wrench on the back. No reaction arm needed on the front. It was all done right here.
Wow. That is amazing. And it's very simple, I can see. And, we talked before even about like the efficiency part of it. I mean, literally as efficient as it gets. Yeah. That's amazing. I appreciate the demo.
Of course.
And what if somebody's now freaking out and they said, but you're going to damage my flange?
Well, I wouldn't call it damage. It is going to make a witness mark. And that's just the act of the washer grabbing onto the material that you're bolting on.
But it's not like a safety issue.
No, it's not. It's not a safety issue. And, anything that you're bolting down, is already, it's a strong connection. It's a connection that's supposed to withstand this crazy force that these bolts are creating. The witness mark created by the washer is not nearly as much as, the forces that this bolt is creating on the surface. It's just small knurl marking that's not going to create any damage. Awesome. Just a simple witness mark.
And then talking about like versatility of the washer itself, I believe, and correct me if I'm wrong, it can be adapted to almost any application. Is that correct?
Yeah, really like what's holding, certain washers in or out of a industry or application or whatever would be, a material spec. So, what type of metal is the washer made out of, or a coating spec, or a finish, or whatever it may be. And we work with our customers, make sure that we understand what the exact requirements are, and whatever they may be, we are going to make that happen.
Yep.
We understand that you have different environments that these washers will live in, and we want to make sure that they hold up, because that's what we're all about.
And that means that the washer, not only besides the size of the washer being adaptable as well, but it's the different coatings that it's made in as well, play a role in different environments and industries and so on, right?
Yes, yeah, exactly. And you mentioned the geometry there. There are certain areas, because of the special geometry of the washer, there are, maybe bolts are tight together, or maybe it's not other bolts, maybe just the area around the bolt is very tight. Our engineering department will work with customers as well and see what geometric modifications need to be made to the washer to allow it to fit here. So maybe we'll cut a couple lobes off that outside pattern or something like that. But our engineering team is very thorough. They make sure to get all the information on that, and with all the custom modifications, they'll make sure that it's still going to hold under all that rotational force. And yeah, they work really well with their customers.
And speaking of customers, do you have any sort of success stories or instances that you know of where somebody switched to the washer and how it improved it, or what their reaction even was to it?
Yeah. One in particular that I actually got to see in person was at the Mine Expo show. That was a few months ago. We were walking around, we saw the Cat 797 mine truck, and we're looking around, and there we saw one of our HYTORC washers on there. And this wasn't one of those projects that I remember working on specifically, but just by looking at it, I could tell what the benefit was for them in that situation. And this was like a lone soldier bolt on the side of this machine where there was nothing around it. You would have needed a reaction arm that was like 4 feet long with a post that was coming down to maybe react off something. So in this scenario, they had a reaction issue. They threw our washer on there. I bet they're getting that job done way quicker, way easier than whatever they may have been doing in the past. Another application that comes to mind are these ball mill liners, which are these huge, almost like tunnel type machines. And the way that I've seen these is they've got bolts in a row that go around this cylinder. And the bolts that are on the same plane, the same level, those bolts are like 5-6 feet apart. And what they had been doing was they had a tool with a reaction arm with a sliding square drive on it. It was 5 or 6 feet long. They have to get like a tower crane up on this tool to make sure that it's getting up, placed correctly. And it was a huge, cumbersome job. They were able to do the job correctly. There was inconsistencies in load between bolts, but that wasn't the biggest deal to them. The big deal for them was how cumbersome the tool was. And we started adapting our washer pattern with the washers that they use on those ball mill liners, and it has apparently been like a huge success for them. So it's another one of those, another example of how the washer can really make a job easier and overall safer as well.
Yeah, and I've seen some of those the custom reaction arms that have been made for certain things in certain situations, and I'm always thinking, I always ask, could they have just used a washer in that? Maybe not always, but in certain cases, yes. And it's just like how simple it is and how easy it is. And when you put it on, I've seen reactions at trade shows where people use it for the first time. They're like, that's it? Right. They like almost don't believe. They're like, your screen is lying to us that's how many foot-pounds. But they're like, no, that's it. Like, it's that simple. But what about people, and this happens in almost anything, where they're just like, listen, we use the reaction arms. It works. It's fine. Even, though it can be cumbersome, or it could potentially have injuries. What would you say to somebody in that situation to try to explain to them why they should jump over to the our washer system?
First thing I'd say is don't wait. Yeah. Using the older methods of using the reaction arm, whether you're looking at the efficiency of the job or the safety of the operator, it's kind of like a ticking time bomb. Mm-hmm. We've seen it with the other customers where they say to themselves, or to us when we're trying to get them to use a washer, no, we don't want to do that right now. We're happy with the reaction arm, like you said. And then maybe a year goes by and an injury occurs. And then they're all kicking themselves and saying we should have made that switch. And that's when they finally do make the switch. A lot of the time is once an injury occurs. So I would say don't wait. Get ahead of the problem. Adapt the washers into your system, and you'll start seeing the benefits immediately.
And then for somebody who says, I would like to use the washers, what do I have to do? What's my first step? How do I find out if I can? Like, what does somebody have to do in that case?
Give us a call. We'll get you in contact with a local bolting expert, local HYTORC guy. They'll come out to you and look at the application that you have and give you their recommendations on, one, will the washer work here? Most likely, yes. And then two, if anything special needs to be done, they'll also be able to advise on that. But yeah, I would say first thing, give us a call, let us know you're interested, and we'll get you set up with who you need to talk to.
Awesome. And then is there anything else you want to touch on that I may not have asked or brought up?
Yeah, I mean, I guess the only other thing that I would touch on is our newer J washer, which is just like our reaction washer, if you're familiar with those. The J washer has a new topside knurl on it that the reaction washer doesn't have, and that actually helps us with holding load under vibration. Okay. So any kind of application where you're seeing vibration and you may have bolts loosening over time, the J washer is the perfect solution for that problem. It has every benefit that we talked about earlier with the reaction washer, plus the added benefit of that locking feature of the topside knurl.
And I've seen some, I know we've done tests in multiple occasions, and then we actually even build our own sort of Junker test that we have that we brought to trade shows. So how well did the J washer do on that test?
Yeah, so the test is called the Junker test. It's an international test for locking fasteners. And I mean, our washers have passed across the board on a number of sizes, all of the sizes. And, that test is, there's a bunch of parameters, and it says you have to hold at least 80% of the load that was put onto that bolt before the vibration was introduced. And I've personally run that test like 100 times on different size bolts that we have, and every single time we're above 80%. Oftentimes we're in the 90, 95% range, which is great, but as far as the test is concerned, as long as you're over 80, you pass, and I have yet to see us fail.
That's awesome.
Yeah.
And to learn about the J washer and all the other fasteners we have, it's just basically would recommend go to the website or give one of our guys a call and then take it from there.
Yeah, definitely. That would be right.
Awesome.
Yeah.
That's basically all the questions I have. So I appreciate you coming on and joining.
Awesome. Thanks for having me.
Thank you.